This illustrative benchmark lab compares 50 DevOps scenarios: build, test, deploy, rollback, and scale across traditional Jenkins pipelines versus AI-assisted orchestration. Same repositories and constraints in the teaching scenario. We measure speed, failure rates, maintenance overhead, and ownership cost. Numbers below are illustrative for learning, not a published third-party study. The 50 scenarios split into 5 categories. Build and compile, 12 scenarios covering multi-language monorepos, Docker image builds, and artifact publishing. Test and quality, 10 scenarios including unit tests, integration tests, security scans, and performance benchmarks. Deploy and release, 12 scenarios from blue-green deployments to canary releases to multi-region rollouts. Rollback and recovery, 8 scenarios simulating failed deployments, corrupted artifacts, and cascading failures. Scale and optimize, 8 scenarios testing autoscaling triggers, resource right-sizing, and cost optimization during traffic spikes. Speed first. Jenkins pipelines average 23.4 minutes per full run: build, test, deploy. AI agents averaged 8.7 minutes for the same scenarios. That's 62% faster. But raw speed isn't the whole story. Jenkins pipelines had a setup tax, agent provisioning, plugin loading, workspace cleanup. Average Jenkins cold start, 4.1 minutes. AI agents had no cold start, they generated pipeline steps on demand and executed them through direct API calls. The biggest speed gain came from intelligent parallelization. Agents analyzed dependency graphs and ran independent steps concurrently. Jenkins ran steps sequentially unless explicitly configured for parallelism. Failure rates tell a sharper story. Jenkins pipelines failed 12.3% of the time across all 50 scenarios. AI agents failed 3.1%. That's a 75% reduction. Jenkins failures broke down like this: 34% plugin conflicts, 28% groovy syntax or logic errors, 19% agent resource exhaustion, 12% credential or secret management issues, 7% other. Agent failures were different. 61% were infrastructure issues the agent correctly detected and auto-remediated, 31% were genuine code bugs the agent correctly blocked from deploying, 8% were edge cases requiring human intervention. Agents failed less and failed smarter. Maintenance overhead is where the business case becomes undeniable. Jenkins required an average of 14.2 engineer hours per week across the benchmark period. Plugin updates, 3.8 hours. Agent fleet management, 2.9 hours. Pipeline debugging, 4.1 hours. Groovy script maintenance, 2.4 hours. Credential rotation, 1.0 hours. AI agents required 2.1 hours per week. Agent policy review, 0.8 hours. Edge case handling, 0.9 hours. Model updates, 0.4 hours. That's an 85% reduction in maintenance overhead. Multiply that by your platform team's hourly cost and the ROI calculates itself. Total cost of ownership over 12 months. Jenkins stack, $187,400. That includes controller infrastructure, agent fleet, plugin licenses, dedicated maintenance headcount at 50% FTE, and incident response costs from pipeline failures. AI agent stack, $62,800. Agent platform subscription, API compute costs, and reduced maintenance headcount at 10% FTE. Net savings, $124,600 annually. For a team of 300 engineers, that's $415 per engineer per year redirected from pipeline maintenance to feature development. Rollback performance was the most dramatic difference. When a deployment failed in the Jenkins scenarios, average time to rollback was 47 minutes. Steps: detect failure, alert on-call engineer logs in, identifies failed stage, manually triggers rollback job, waits for rollback pipeline, verifies state. AI agent rollback, 3.2 minutes average. Steps: detect failure, automatically revert to last known good state, verify health checks, notify team. The agent didn't wait for a human. It had the deployment history, the health check results, and the rollback procedure in memory. 47 minutes versus 3.2 minutes. In a customer-facing outage, that's the difference between SLA breach and SLA compliance. We're data-driven, so here's where Jenkins still wins. Mature ecosystem: if you need a niche integration, there's probably a Jenkins plugin. Extensive documentation: 15 years of Stack Overflow answers. Team familiarity: your senior engineers know Groovy. Complex approval workflows: Jenkins supports multi-stage human gates that agents are still learning. If your team is small, your pipelines are simple, and your Jenkins instance is stable, the migration ROI might not justify the effort yet. But for any team running more than 20 pipelines with more than 5 engineers maintaining them, the numbers in this benchmark are decisive. Don't take our word for it. Run your own benchmark. Select 10 representative pipelines from your Jenkins instance, pick a mix of simple and complex. Deploy an AI DevOps agent in shadow mode. Run both pipelines on every commit for 30 days. Compare execution time, failure rate, maintenance hours, and rollback time. Document your findings. Present to leadership with your actual numbers, not industry averages. Every organization is different. Your Jenkins instance might be better maintained than average, or worse. Your agents might perform differently on your specific stack. 30 days of parallel running costs almost nothing and gives you data nobody can argue with. The teaching takeaway is directional, not a guarantee. In controlled comparison scenarios, AI-assisted orchestration often looks faster, fails less often on repeatable paths, needs less plugin babysitting, and can cut ownership cost versus a sprawling Jenkins estate, but your stack, skills, and constraints decide the real outcome. These numbers are illustrative for learning, not a published third-party study. The question isn't whether agents will replace every Jenkins instance overnight. The question is whether your team will measure the shift deliberately or wait until maintenance becomes unsustainable. Run your own benchmark. Get your numbers. Make the decision with data. I'm AI DevOps Daily. Next time, we tackle Kubernetes cost optimization with AI agents.